So thank you very much. I'm going to talk about how to produce very rigorous research, and even more importantly, how to communicate this, how to demonstrate this to our peers. So in essence, I would like to give an extra shove to that javelin that Adam threw in the morning. Yes, I believe that we can increase the credibility, the rigor of social science studies, even to an extent where replications might become a little bit redundant. But a little bit more about that later. So So most of the people here in the audience would probably agree that we cannot fully trust or fully rely on every research study published in the literature right now, mainly because we know that there is a very poor replication rate. Only about half of the studies that we see in the literature would be actually replicated later, or even a smaller amount. And so the issue on top of this is that there are no good indications of which study is trustworthy and which study is not trustworthy, which one we can rely on and which one we cannot. And this means that there is growing generalized mistrust in research on the field. And not only the unreplicable studies are suffering from this, but really good studies are also suffering from this. My study, my research has less value if half of the people in the field don't believe that it would be replicated. So it leads to kind of a devaluation of research on the field. And so fortunately, the reformist movement has come up with some solutions for improving replicability. Most of the solutions has to do with improved transparency, which we are supposed to pre-register our research plans, share our data, code, materials upon publication. But we have to be honest with ourselves. Even though some of us call this transparent research, some of us even go to the lengths of calling this radical transparency, we are actually not transparent about the research process itself. We are transparent about our research plans, and we are transparent about the results and the materials we are comfortable to share. But there's a lot of things between the plans and the results. Namely the whole study, the whole data collection, the sampling is happening between these two things. And that process is completely happening still in the dark. And a lot of things can go wrong in that dark area that is untransparent at this point. So there are few things listed here that can happen even if a study is completely pre-registered, a perfect pre-registration, all materials, data, code are open. We would still be blind about any mistakes or intentional flexibilities on the selection process, sampling. We would be blind about any protocol deviations, like breaking of the blinding, the randomization process. Even though we ask people to pre-register their stopping rules, we have no way of knowing whether they actually use those stopping rules or not. I can restart the study if the research data doesn't go my way, and I can use kind of flexible ways to abandon my study. I have seen many studies while I'm reviewing the papers, claiming that, okay, we ran out of resources, so we, even though we said that we will collect this amount of data, we collected only this amount, or the postdoc or the PhD student left the lab, so we had to stop. These kinds of things are still, these kinds of flexibilities are still out there. And a lot of things, of course, can go wrong during the data handling process. starting from mild things that would only increase noise, like data entry errors, but spanning to very influential bias, like fabrication, result-driven outlier exclusion, deletion, or imputation of data. So all of these things we are completely blind about right now, and we only know about these things if the authors have the courtesy of sharing these protocol deviations with us. And there's always the possibility of retrospective pre-registration as well. So the idea is that you would do this study beforehand, p-hack your way or hark your data, your results, and after you have seen your results, you would do the pre-registration, wait a few months to make it realistic, and then all of your hypotheses would be confirmed. And you might think that, okay, yeah, that's a clear case of fraud. And so as a clear case of fraud, it must be very, very rare. Think again. So in medical science, pre-registration has been around for much longer than in psychological science. And the recent paper shows that 67% of medical research is pre-registered retrospectively. And this data only covers the very blatant cases where the pre-registration happened within a few days of submission to the journal. So it doesn't cover any of the cases where the researchers actually went into the trouble of covering their tracks. This is a serious possibility which we might have to deal with in psychological science as well. These solutions are inadequate to really show the trustworthiness of any single individual study that we look at. And Andrew is right that we don't owe trust to any of the individual studies right now. But I want to live in a world where people have to trust my study. So if I go to the bank and I give my money to the bankers, I have to trust them that they won't steal my money, that they won't just manipulate the numbers on the records there. For the whole thing, for the whole system to work. And we have come up with technologies and safeguards to make this trust verifiable. And I think it is possible to do this in research as well. We just have to work toward this and improve the rigor in science, social sciences, and we will get there eventually. So I want to live in a world where Andrew owes me trust, or owes my research belief that it was conducted in the way I wrote it down in my report. So some of you might think, okay, we don't really need trustworthy original studies. We only need very transparent protocols so that we can replicate each of the findings. And this way, the replications themselves will show whether each of the findings are reliable or trustworthy. But I think this is not the only solution. So waiting for the replications is time-consuming. Replications are costly, and we cannot replicate each and every study that we rely on ourselves. So we have to rely on others to do the replications for us. And then we get into the exact same problem of whether we should trust the replication more than the original study. We get into the exact same issue that we are not able to provide verifiable evidence for the trustworthiness of our studies. And of course, there's the big bane of replications and original studies as well, the post-hoc criticisms. I will talk about that later as well. So I'm arguing in this talk that we need to develop methods that help us to create trustworthy research and ways in which we can help our peers to verify this trustworthiness about our research studies. So here's where our research project comes into play. So we have decided to do a large multi-lab replication of one of the BAM 2011 experiments. And if you don't know about the BAM 2011 paper, I think you should seriously check it out because it's a historical landmark on the field of at least the psychological reformist movement. It was one of the first sparks which kind of blew the fuse on many people and started a whole lot of commentaries, and which later served as kind of the first sprouts of the reformist movement. So the study is, or the paper details a 9-study experiment series. All of the experiments are about ESP, extrasensory perception. And 8 out of the 9 studies showed support for the ESP theory, so the parapsychological hypothesis. More specifically, the experiments were all about precognition. So whether people can get information from the future and use them in their behavior. And so the studies you would need to imagine are, for example, experiment 1, people would see 2 curtains on the computer screen. They are asked to guess which one of the curtains hide an erotic image. And the other curtain, it just hides a blank gray image. And what they are not told, the participants, that after they choose, the randomization only happens after they chose. So this makes it a precognition experiment, something like this. And yeah, this is not a representative sample of the erotic images. Yeah, there were some neutral images as well in the original study. So this whole thing started as a thought experiment. Let's imagine a world where there is a precognition effect. What would be the study that could prove this to the scientific community? And we had to realize that there is no such study. There is no such study with our current toolkit that would be able to convince the skeptics about the existence of such an effect. So we thought that, okay, this goes to the other way as well. So there is no such study which would be convincing enough for the proponents of the theory that would convince them about the non-existence of an effect. So we thought that okay, we would actually replicate one of these experiments, and during the way of producing this research, we will devote all of our resources to creating these credibility-enhancing methodologies and tools that will help us to produce a convincing and reliable research study. And one of the first things that we needed, we realized, was that even if we produce the most convincing and most reliable, credible study out there, we are bound to get some post-hoc criticisms. So if we do it the regular way, we will get criticisms for from either the proponents, if we find a null effect, or the skeptics, if we find a positive effect. So what we came up with is a consensus design process. So this process means that we invite all the stakeholders on the field who are researchers to contribute to the study design. So in order to make our study robust enough and to protect against any post-hoc criticisms, by engaging these researchers from the get-go. And we did this by doing a systematic review of the literature and reaching out to every single author who was on papers who have ever cited the BAM 2011 paper or the subsequent meta-analysis that was published in 2016. We also included some other stakeholders that we knew had contributed to these papers, and we opened up the call as well to all of the invited stakeholders. We also said that they can nominate others to participate in this review process or in this design process. There were some eligibility criteria. You can check them out on OSF. It went similarly to a regular review or a registered review process. There were some iterative back and forth feedback with this review panel. There were 29 researchers in the final consensus design panel. And in the end, we were able to agree on what is the appropriate protocol for this replication study, what are the appropriate safeguards against researcher biases and questionable research practices or flexibilities, whatever you want to call them. And one of the cool things in this project was that we were also able to agree or reach an agreement about the interpretation of the results. So we have pre-registered conclusions for each possible result of this replication project. And this was one of the hardest part of the project, actually, to come up with a text that both the proponents and the opponents of the theory mutually agreed upon for each eventuality or each possible outcome of this research project. Yeah, I won't really go into the details, but you can check these pre-registered conclusions as well on OSF. So the important thing maybe is that we don't claim in either case that precognition exists or doesn't exist. We are talking more about whether it is likely that researcher biases and publication bias could be enough to explain the positive results in the original study, or whether it is unlikely that these biases alone can explain the original results' positive effects. Okay, so let's go into the interventions or methodological tools that we came up with during the whole study design process to increase credibility. So one of the things we realized is that we need to extend the transparency into this transparency gap that we have currently. So we need to extend the transparency onto the data collection process itself. There was already a method out there for doing that, which is called the born open data, which means that the data is shared while the data is being collected. This way, the other researchers can follow the accumulation of the data. However, there were some issues with this implementation previously. So Rauder and colleagues implemented it in a way that they pushed all of their data at the end of the day, which might leave room for some doubt about whether anything was manipulated with the data between the time of collection and pushing to GitHub. So another issue was that this born open data process requires observers. So people who actually care about the accumulation of the data. And if you don't have such people who are constantly kind of logging into your data set and comparing it to later versions, there is not too much impact for this born open data procedure. So we came up with direct data deposition instead, which means that we don't collect data locally at all. we collect data immediately directly to a third-party version controlled repository. In our case, this is GitHub, but it could be OSF as well. So that's where our data lands when it is being collected. This way, we have a verifiable and unmodifiable record of the data being accumulated. And even if a researcher only checks our data and this whole process, at the end of the study, they would still be able to roll back time and see how the data was accumulated and see any kind of manipulations that happened with the data. Another issue was that the born open data process requires people who are data savvy, so who know how to compare the versions of the data sets and to analyze the data. So what we also devised is real-time research reports. So this means that we immediately analyze the data as it is being collected, and we create a research report, if you will, a whole paper automatically, algorithmically. And this way, we are able to increase the inclusiveness of this process. And people who don't know anything about data management or data analysis can still benefit from this intervention. So another approach that we take is to demonstrate protocol fidelity in other ways. So we are using computerized data collection and step-by-step manuals for our researchers and experimenters. We use study session checklists, and we require the experimenters to submit a video recording of a mock study session at the end of their training, this way showing that they are able to deliver the experimental protocol as intended. All of these interventions are supposed to decrease or minimize the risk for mistakes and other human factors. We also keep laboratory logs. So each research session has a laboratory log with a bunch of metadata about the research session and a log of any unexpected events or researcher decisions that needed to happen there. We also test the adequacy of our research protocol or pre-registered protocol, not just through the registered report process, but also by our pilot study. So, of course, pilot studies are not innovations. They have been around the psychological science for a long time. But I think they were not really used to demonstrate credibility before. So how this a pilot study plays into credibility is that it can test your previously designed protocols adequacy and see whether there are unexpected events that you didn't think about, which can be included in the protocol to increase the robustness of your protocol. And we also have a bunch of fraud prevention techniques. So one of the cool things about doing this whole process with the parapsychology experiment is that the gloves are off here. So if we would do this whole process with any regular psychological science experiment, Andrew also mentioned this, that people are just polite. There are social norms. We don't say in our reviews that you probably committed fraud here, or you probably did a mistake here, because that's just not really within the social norms there, especially if we don't have reliable evidence to prove that. However, with the parapsychology experiment, and especially with the BAM 2011 experiments specifically, everything is on the table. And we got a lot of suggestions about how we can commit fraud in this situation, and we had to devise methods to put these criticisms or possibilities to rest. So we are, instead of using local data collection softwares, we are using a centralized server to run our data collection code. And this software is, or the contents of the server are constantly synced with GitLab. So this way we are able to verifiably show that the code that was running during the whole experiment was the same throughout the whole study life cycle. Yeah, we also collect server logs and make it public. And the direct data deposition I already talked about, which also helps us to show a verifiable record of the data accumulation and that the data was not manipulated in any way. One issue with relying too heavily on transparency is that we are generating data more rapidly than we can process the data. And we are starting to run into the issue of who is supposed to check all this open data, who are supposed to compare the detailed pre-registration to the experimental report, who are supposed to check the open data. And especially nowadays, where we are getting more and more aware about the labor discrepancies and the free labor that researchers are doing by doing the reviews for the journals, it is getting more and more uncertain who is supposed to take on this extra burden of checking all the new open materials. So to not get into this shared responsibility issue, so where people are thinking, okay, so the data are open, probably someone should have checked it. I don't know who, but I trust that someone checked it. Instead, we are using external auditors whose dedicated task is to check all of these materials. They are not on the study author team. They are paid to do this job, and they have a protocol for checking all of the materials. And so because of this issue with transparency and just too much information, I think that automation is more a solution for the credibility problem than the increasing transparency, or there is like a diminishing return for increasing transparency after a while. I already talked about these interventions. So the research report is currently under registered report stage 1 review at the Royal Society of Open Science, but we are still recruiting labs to join this replication project. So if you are interested in joining the replication, then you can send me an email or just visit this sign-up form where we ask for contact information so we can enroll you into the group of collaborating labs. And I would like to acknowledge the funding from the Bio Foundation, who are generously funding our project. And of course, the whole outer team, Balázs Acél, Bence Pálfi, Barnabás Szászi, Péter Szécsi, Mark Zubka, Martin Kovács, Bence Bakos, Denis Cusino, and Patricio Tresoldi, who have actively contributed into writing up the pre-registration. And of course, the whole consensus design panel, you can see the names of people who contributed in this consensus design panel. These are only people who agreed for their name to be shared. And you can see some familiar names, maybe, for example, Dario Bem or Daniel Lakens or Eric-Jan Wagenmakers was also there to drop some names. And thank you very much for your attention. Yeah, please.
How much does this all cost?
Yeah. If you want, I can email you our budgets.
I mean, it just seems a horrendous amount of effort, of huge numbers of incredibly eminent people putting in immense amounts of time to very, very carefully and precisely check that a physically impossible effect isn't there.
So the project's main aim is to develop the methodologies to increase credibility. And I think, so there are multiple sides to the answer. So one of the reasons we are doing this with the BEM 2011 experiment is that we just, as I said, if we did it with any other type of experiment, we wouldn't get that big of a coverage of all of the criticisms and biases that otherwise we would not be like, the reviewers, the panel members wouldn't even mention these kinds of things. And on the other side of things, so I really don't know why you say that it is an impossible effect. So the effect is that there is a correlation between the behavior of people and later random numbers. So there are all kinds of
yeah, but BEM is on record as advocating p-hacking.
Sorry?
I mean, BEM is on record. He's written a textbook chapter where he explains to people how to p-hack and what a very good idea it is.
Yeah, do you think that would hold up at court, that he did that in this particular study?
Sorry, I missed that.
So do you think that that is evidence that he did that in this particular study?
He's got form.
I mean,
okay.
Well, I get it. I get it that you.
I mean, I'm just feeling that this is replication gone mad. And if you're developing methods that could be applied more generally, I suppose you could say that that's a good case. But I do worry that this is a huge investment of time and energy, and it could be perhaps, these resources put to a more interesting and useful question for society. But that's...
So. Yeah, thank you for the question. I think, I mean, certainly some people think that this is an interesting research project. A lot of people have already joined the collaborating labs. We got funding from the Bio Foundation. So, I mean, you don't think that this is a worthwhile effort to put your resources in it, but others think that it's a worthwhile effort. Yes. Please.
Thanks for your talk. I'm Dawood Podketer from the Templeton World Charity Foundation, and I enjoyed listening to this because I've tried to do something similar for competing theories of consciousness. And it took about 2 years to set it up, and I also won't say how expensive it is, but... And we did something similar, but the question I have is how scalable is this? And the reason is in my conversations with others, I've heard people talk about opportunities to expand this to other controversial topics in science where there are competing ideas that could, in principle, be resolved through some sort of experiment. And that could be whether or not the adult brain still undergoes neurogenesis, or whether the Brach hypothesis of Parkinson's disease is correct, or whether a dysfunction starts at the synapses. There are these challenges, but looking at everything you've done, it seems quite difficult. And how easy is it to scale that? Now, really, now that you've done the code and all those things, can you just apply it like a template to everything else?
Yeah, so I think our methods are really transferable to a lot of regular psychological science studies. For neuroimaging, some of the examples you had were neuroimaging studies which have like vast amounts of data, and it might be hard to directly apply or direct data deposition technique to that particular type of data. But I think with collaborating with some of the labs that do work on archiving and depositing neuroimaging data, we could make it happen. We are working currently on a guide on how to set this up, the direct data deposition and the real-time research reports. So I think it is quite transferable to other research. Scalable, I'm not sure what you mean by
well,
that.
does it require someone like yourself to bring everyone together and keep it going forward? Or can this just be a set of instructions in an application form, for example?
Yeah. I think it can be just a set of instructions. And I don't believe that all of these methods that I described need to be used in every case and every study. But we just wanted to go for very comprehensive coverage of this transparency gap that we identified.
Thanks.
Thank you.
So, yes, so if you could elaborate a little bit more on how you actually got people to agree on the interpretation for the same result, because I mean, you'd expect that Daruban or Dorothy here might just not look at the same data and legitimately not have the same conclusions, and like being strictly Bayesian, if people have been exposed to different stimuli or integrating different information, you might expect that their priors are different and they should not. So how did you work that out?
Yeah, so we did that through the consensus design process. In the first iteration of the consensus design process, we asked the people about what would be the required level of confidence for them to think that there is really an effect here, or to think that there is to be convinced that there is probably no effect. So we went from there, this way establishing kind of the priors of people. We asked it in p-values and in base factors. So what would be the required base factor that would be convincing for you enough to say that, okay, something might be here that needs further investigation. And after that, we just proposed an initial set of conclusions, which were outright rejected by both parties, so by both the proponents and the opponents. But slowly but surely, by communicating with each individual one-on-one, we established a kind of a set of statements that both parties were okay with. And this means that our conclusions are very cautious, so to speak. So we never say that ESP exists or it doesn't exist. We are not saying that it was p-hacking all the time. We are saying stuff like the results found in this study are in agreement with the predictions of the ESP theory and these kind of things. And the other case, or in both kinds of cases, whether the null hypothesis or the alternative hypothesis is found to be true, we are saying whether it is likely, these results show that it is likely that the results were just the effect of known researcher biases, or whether it is unlikely that they are able to explain the effects. The short answer is it required a lot of one-on-one communication back and forth with each of the panel members. And then in the iterative process, they were able to see others' comments as well. Yeah.
Jonathan Schooler, UC Santa Barbara. I'd like to commend you for taking on this very ambitious project. and just remind people that there has been research that has been consistent with the ESP conjecture for a long time, and many meta-analyses that have been in support of it, including the one that you listed there on the BEM paradigm, finding positive results. To conclude that the results are impossible and therefore not worthy of scientific investigation based on one's a priori beliefs seems unscientific. And so it seems appropriate to, given how important it would be if such phenomena exist, even if they are unlikely and quite possibly the result of p-hacking and other things, seems worthy of further investigation. So I commend you on that. I wonder if you could tell us sort of what the status is of the project currently. Are people actually collecting data? When do you anticipate the data collection to begin? And if people are seriously interested in becoming involved in this project, what would that entail for them?
Yeah, so the project is currently under stage 1 registered report review. So we are not collecting data. We have finished the pilot study. So we already have more than almost 200 participants worth of data, which is twice as much as in the original experiment. But yeah, surprise, surprise, the original experiment was very underpowered. So what it would mean for people to join, we expect to start data collection in October. Maybe that's very optimistic, of course, because there might be some revisions during the registered report process. So we would like to start data collection in this semester. And those who would join would do the ethics submissions, and after they have them, they would have to go through the training that I mentioned. So each experimenter who does the experiments would have to go through a training, and then in the end submit a video for us to verify that they are able to produce the research protocol as intended. I think our process is pretty similar to the other multi-lab replication studies that are out there.
And how many participants is each lab committing to run?
So we ask for 100 per lab.
Thank you.
Hi, David Ornstein, University of Exeter, Economics. I noticed you introduced or took a number of measures to verify and to show that the research could prove that the data that they collected had not been tampered with, modified, edited. I think that's a rather, this was mentioned before, I think a rather important sort of hole in the dam is that at the moment it's very easy to tamper, change one's data after it's been collected and then share it, and no one would be the wiser. Do you think it would be feasible to set up a system, and have you gained insight into the feasibility of setting up a system that we could all agree to that would enable people to have witnesses on their data or direct depositing of their data having been registered? And how would you suggest we go about putting that into practice?
Yeah, so I think this is very feasible, and so that's why we are working on the guide for every lab to be able to reproduce it at their end. And once the data is at OSF or at GitHub, it is practically protected against any manipulation.
Just to be clear, how difficult would it be for us to just establish this as a norm in social science experiments? Or something that people could opt into, but if you didn't opt into it, you wouldn't have that level of having assured that your data is credible, verified.
So I have no idea how hard it would be. I mean, it would take a Brian Nosek what I mean is that I have never engaged in such a large-scale effort. So I have no idea how hard it would be to push this through. But I think this is a very easy to implement thing, which you can do yourself in about 3 hours using the guide that we put together. So I think this is not a big effort if you have a research assistant who can turn on a computer.
Colin Kammerer from Caltech. I am a behavioral economist and Metascience hobbyist. And it seems to me, in thinking about triangulation, which came up a bit yesterday, this is an interesting case because what I think fosters a lot of skepticism about ESP is the implausibility of a physical or biological mechanism. And so number one, I want to know if you've discussed that in your group, and is that going to be part of things you discuss? And number two, a way to kind of sharpen the point is, suppose you find a substantial effect that you believe and you report that out. You can imagine a series of experiments that would try to pin down the mechanism. And it's hard for me to think of any that Dorothy would certainly think are a waste of time and money. But has that been part of your discussion, is sort of this an aftermath and what happens next?
So we deliberately didn't focus our discussions on mechanisms because we knew that the consensus panel wouldn't be able to arrive at an agreement there. So it would be setting us up for failure. But this is not the main focus of the project. Nevertheless, some possible mechanisms were mentioned. I have heard a lot of them. Some of them don't require psychic abilities, but all of them are pretty wild. So all of them are pretty unlikely. I can give you some examples over a beer or a single malt scotch. I learned.
Okay,
Yeah.
we are at the end of the time. Thank you very much.
Thank you so much.